so much. Hi, everyone. I'm Karen Tucker from the Churchill Club. Welcome to our program called The Future of Batteries. Energy production options for applications like consumer devices, electric cars, and the home continue to grow and mature, but transmission is still inefficient. Visions abound, but we are still waiting for the big battery breakthrough. So the aim of this conversation is to explore the current state of battery technology and research and implications for innovation in how we produce and store energy, as well as what that implies and will enable in the times to come. So here to weigh in, we have a diverse and accomplished set of speakers: Qichao Hu from SolidEnergy Systems, Mark Perutz from DBL Partners, Rajaiah from Advanced Microgrid Solutions, and Eric Wesoff from Greentech Media. And here to lead them in conversation is Kevin Collins from Accenture. We really want to say thank you to Accenture, especially Kevin and then Julie Rosendahl as well, for their partnership in enabling this program in the first place. Please give them a hand, would you? Thank you.
They're sponsors. No Windy everywhere else sponsors.
Churchill Club is a nonprofit business and technology forum operating in the Bay Area now for 3 decades. We present up to 30 programs every year in support of people like you who are working to advance innovation and economic growth and also social good. We try to choose topics that are ripe with opportunity, that are not already over-discussed, that there is something new to add to the conversation. And we ask our speakers to share fresh insights and information and opinions, never to pitch or promote on our stage. We are member supported, and we invite others in the audience to consider joining us. We would love to welcome you. If you're tweeting, please do use the hashtag Churchill Club, and you will find other Twitter codes in your bulletins. And with that, please, let's give our warmest welcome to Kevin, Qichao, Mark, Katerine, and Eric.
That's me. Let's go.
I think we ought to go up, right?
Let's go.
Thank you.
Thank you, Karen, and thank you to Churchill Club for just continuously putting on these interesting events. I love going to them, and the ones I don't go to, I try to watch on the website. Tonight's session is called The Future of Batteries, and I sort of felt like it could be called The Future of Everything because the impacts are so broad, but we felt that that was a little bit immodest, and so we kept it where it was. Our objective for tonight, our goal is for you to walk out of here with a perspective not just on where the science is going, but on how the industry is changing and what it means for the applications and the things, all the way from the grid, all the way down to the cell phone in your pocket. We will definitely save quite a bit of time for Q&A. We have an amazing group of people registered, a lot of interesting perspectives in the room, so we will cut some time for you all to ask questions of these esteemed panelists, and so we'll certainly do that. I'm going to ask each of these folks to introduce themselves briefly in just a couple of minutes, but before I do, I just wanted to spend maybe 2-3 minutes and tee up what we're going to talk about tonight. So, battery technology. I have a friend who's a researcher, a battery researcher, and I sat down with her and talked to her a little bit about, how do you think about this and how do you talk about the space? And she said, whenever I meet with people who aren't in this space, I always start off by comparing battery technology to VCRs. And she said, VCRs allow me to time shift media consumption, batteries allow me to time shift power and energy consumption. And she said that the grid and the way that the power system is set up now is meant like old network TV. It's meant for immediate consumption, it's out there, and if you're late for Dynasty, you're late for Dynasty. And so batteries really changed that whole game dramatically, and they allow me to time shift and do things when it's cheap and when it's efficient and when it's effective. There's an article, I just want to get this right, excuse me. There's an interview recently that I saw on The Verge. Mark Andreessen gave an interview about batteries, and he was talking about flying cars and a million things, but then he said this, he said, the single biggest X factor in the next 5 or 10 years for all of this stuff will be if there's some fundamental breakthrough in battery technology. Then basically all of the questions of what's possible get reopened. If I had 10 or 100 times the amount of power that lasts 10 or 100 times longer, then we'd be building Iron Man suits. Then all kinds of things start to happen. So it's important. I mean, maybe you saw the governor announced that we're trying to get 1.5 million electric vehicles on the California roadways by 2025. The largest, most expensive component of an electric vehicle is the battery. If you think about your cell phone or your tablet, a key part of the user experience is the battery. And there's a funny cartoon I saw that said, in the old days, the biggest fears were like public speaking and spiders, and now it's no Wi-Fi and empty batteries. So it's really a key part of our experience of the devices that we interact with. And then also, if you think about our green solutions, our climate change solutions, they all depend on this technology. So it's a big deal. And from a consumer standpoint, what we've seen is that the devices that batteries interact with seem to have innovations every year, and all kinds of crazy new stuff coming out, and all these new breakthroughs. And at least as a user, what we don't see is the same thing in the battery itself. Now, we have manufacturing innovations, and we have power sipping chip innovations and algorithm innovations and all kinds of things around it. But the core lithium-ion battery is kind of not dramatically different than what we saw in 1991. Now, a lot of people in this room are kind of cringing and saying, not really true. So we're going to get into that, and we're going to talk about that with this group. So we are fortunate to have on this panel, as Karen said, a very diverse and very interesting breadth of experience. And so what I'd like to do is just give everyone a minute or two to introduce themselves, talk a little bit about what they're working on, and then we'll dive into the content. Okay? Thank you. So Qichao, you want to go first?
Sure. My name is Qichao. I'm the founder and CEO of a battery company based in Woburn, Massachusetts called SolidEnergy Systems. And we develop batteries for high-altitude drones, cell phones, wearables, and also cars. So we started back in 2013, and then actually when we started, it was the same time when another local company in Massachusetts, A123, went bankrupt. So we've seen a lot of the noise and failures in the industry, and from day one, we are determined to change that. And actually, we are the only company that actually formed a partnership with A123. When A123 went bankrupt, we were the only company that actually moved into A123 to leverage all that asset, that facility. So. We have a unique model in the sense that we don't try to compete with the large battery manufacturers, but instead we actually leverage that capability. Thanks for the invitation.
No, glad to have you. Thank you. Mark?
Hi, everybody. My name is Mark Perutz. I'm a partner at DBL Partners. We're a venture capital firm, and the DBL in our name stands for double bottom line. So what we mean by that is, like pretty much every venture capital firm, we're looking to maximize financial return, but like pretty much not every venture capital firm, we're looking to also maximize social and environmental impact. And that led us to clean tech pretty early on. We made our first clean tech investment in PowerLight, which was then acquired by SunPower back in 2005, and have done a lot of wind, solar, green building materials, transportation, and energy storage. We've got 5 energy storage investments across the energy storage value chain, from folks who are developing projects to folks who are making batteries. We're investors in Tesla, SolarCity, Primus Power, Powergenics, and AMS. Oh, one question for you guys. Can we get a show of hands and see how many people here, there's going to be kind of 2 questions, two surveys. One, the first question is how many people here work in an industry that is involved in storage of batteries, and the second question will be how many people are not, and we can see who didn't vote afterwards. So first question, how many people work in an industry that's involved in energy storage or batteries? What do you say that is, like 30%?
Well, yeah, 25, 30%.
And how many people are not involved in that at all? More like 70% looks like. And any people didn't vote and want to vote now? All right.
Yeah,
cool.
Thanks.
Good to know.
That's good. Thanks.
Thank you.
Katerine?
Yeah, hi. My name is Katerine Rajaiah. I'm the Chief Commercial Officer of Advanced Microgrid Solutions. We are a business model company, so we do not develop our own battery. We actually come up with a business model on how to commercialize the batteries in order to provide grid support at mass scale, because the supply of energy rarely matches the demand for energy, which either causes brown and blackout or power spikes. We're venture backed, and I've been in the energy industry for about 12, 15 years, and had a tremendous opportunity to join a really visionary innovator, our CEO Susan Kennedy, about 3 years ago, and jumped at the chance, and we grew our company from 2 women and a dog to now 50 people and some contracts with some major utilities.
And a dog.
And a dog.
Eric?
My name is Eric Wesoff. For the last 8 years, I've been the editor-in-chief of an online publication called Greentech Media. We cover renewable energy, solar, batteries. And unlike our panelists or people involved in the battery industry, I have no dog in the fight except truth, justice, and the American way. And for the last 8 years, when a new battery company comes out, they typically pitch, also known as lie, to me for as long as they can. My job is to try to sort out and parse the truth from what I'm being told. I think a warning is in order. There's a quote from Thomas Edison from 1883 in an interview in a magazine called The Electrician. It's a great interview, actually, and many of the things that we're addressing now about battery power and safety and its worth are addressed in 1883. But the one thing he did say is that anybody involved in a secondary battery, it brings out their latent ability to lie. So, not anybody here on the panel or in the audience, but when you're talking to battery people, be careful.
Should we take a revote now of who's involved in the industry? that we've done that?
There's actually a saying in the battery industry called liars, damn liars, and battery suppliers.
Okay, so we've got an ambitious agenda here. We're going to try to talk all the way up at the grid level and what's happening there, and then move all the way down to the device level, all in a short time. And so I think what we should start with is start at the top. And I guess we saw, let me see, I just wrote it down because I wanted to make sure I got it right. So we're starting to see storage solutions at every step in the chain, all the way up and all the way down the chain. I just saw a thing today, actually, that was announced earlier this year, where LA is bringing the world's largest storage battery will be brought online to help with peak power demand. 18,000 lithium-ion cells delivering 100 megawatts per hour for 4 hours. So basically, peak demand, instead of relying on an old school generation technique, is now going to be stored in a battery to help LA with peak demand hours. and I also saw at the same time another comment that said that distributed power, like power away from the grid, is going to surpass power at the grid in the future, and so in the near future. And so that fundamentally changes the way the grid works. And so I think just as a very starting point for the panelists, how do you think about that problem? And as you go from this network TV model of create it and push it out to this other model of millions of little data points of storage everywhere, how does that change the way we interact with the grid, and how does it change the way we interact with our devices? You want to go to start on this one, or should I just pick someone?
It's a tough question.
Go ahead, Eric. You're the independent.
Well, everything up till now has been, all right, at least before the electrical grid, everything was distributed, right? But once we had an actual electrical grid, all power was generated by gigawatt scale, 100 megawatt scale natural coal plants, which apparently is a booming new industry, in case you haven't been paying attention. Natural gas peaker plants. As the ability to generate power with a solar panel gets cheaper and cheaper, it starts to make sense for somebody to put it on their roof and control their energy on their own. It's the same model that's applied to phones and computing, right? I mean, that seems to be the model. Unfortunately, there is a monopoly distributor in the way, and that's the utility. And so there's not a free market going on of this beautiful rush towards distributed generation because there's a regulatory construct around it already. I hope that makes so. Also, the pushing batteries everywhere is not necessarily a green technology. You can be using low, dirty batteries, and you can be storing energy from coal. And therefore, it's obviously not a green, there's not a green aspect to the entire battery chain that's going on there. So distributed generation is good. It looks like it's good, even in solar, but there are arguments on either side for the large battery you spoke about in Southern California. I think that's a 100 megawatt hour battery that's there to replace, to a great extent, the SONGS, the San Onofre nuclear generator that went offline. That's a great application for batteries and distributed generation.
If you're a building owner, Katerine, you probably are living in the middle of this, right? If you're a building owner, how do you think about the trade-offs, and how do you think about, hey, this is a good idea for me, this is a bad idea for me, I'll stick with the grid? How do they think about it?
Yeah, so our company, AMS, we're fundamentally different than other companies that install storage in large buildings or industrial user sites. What's different about us is that we do not just sell batteries and say, okay, goodbye customer, now you figure out how to use it. We also have an element with which we lead, in where we get the utility involved right away. There are companies that build a business model around taking large customers off of the grid. Our company doesn't do that. Our company was born under the premise of, if you put enough distributed generation at the grid edge, but you give the grid some visibility and control over that generation, that can act as a balancing tool to supply and demand. It's never been done before. There were these large generators, coal, natural gas, nuclear, etc., and there were users, very large power users, very sophisticated power users, that had no control over how they took that energy from these monopolistic companies. We're introducing an element where these large energy users can start actively participating with the grid.
So it becomes like a three-tiered system. So there's grid power that pushes out.
Yeah.
Now there's this edge power, and then there's what Eric was talking about, right? Solar on the roof, battery in my house, car in my garage.
That's exactly right. Okay. So we install batteries for dual purposes. Again, it's never been done before. The first purpose is to supply certain services, these balancing services, to the electrical grid. The second function is to provide this DVR load shifting that you cited at the beginning to the large consumer, essentially enabling that consumer to take advantage of lower power prices. Dual function.
And so how does the utility think about that? I mean, to me, when we're talking at this level, at the sort of grid to edge level, what I'm trying to get my head around is, it used to be the monopoly controlled everything and they just did it. And now you're trying to push some levers to the edge. How does that interaction work?
Yeah, we have some very large contracts with some of the largest utilities. And that is because for the first time, we're giving them certain control over that grid edge asset. Typically, they viewed those as distortions. They didn't know if a customer was putting panels on until the customer put the panels on and was drawing less energy. It was viewed as a nuisance and distortive to the power operator's ability to balance that supply and demand. Now, if you do this in concert with the utility as a willing participant, you can start getting scale with some of these
Katerine,
projects.
what you're trying to do is you're eliminating the need for a peaker plant. Is that the real application? So a utility, the air conditioning is being used to on a hot summer day, and the utility is going to have to turn on a very expensive peaker plant that's only used a couple of percentage points of the year. Instead, they're going to pull that necessary peak power from the batteries. Is that
That's the idea.
The killer app?
If you put the batteries in the right place, which is urban centers, the most constrained circuits, and lower the demand at peak times, the utility doesn't need to turn on that highly polluting peaker plant to balance that demand. That's correct.
So I read that something like 5 to 12% of the power gets lost in the distribution. Does this get in the way, does this help that problem as well, or is this completely independent of that?
It does solve some of that problem. So less power can now be delivered during peak times because the customer is self-supplying partial power from their batteries. Additionally, there's a myriad of services that the batteries provide to the utility: capacity, voltage support, optimization along the circuits and the lines. So yes, it goes to mitigate that point as well.
So let's put on our like super far range binoculars. Everybody has this stuff. Now we've got your solutions or solutions like it out in the market. We've got batteries in my house and we've got stuff all over the place. What happens to the utilities? What happens in that world? How do we think about that one?
We still think utilities have an essential role. First of all, we never size our batteries to the customer's entire load. Second of all, the utilities will always be responsible for the transmission and distribution of energy. And we think utilities' financial and operational support is the key to scale in this industry.
Okay.
If I might jump in on that.
Yeah, please.
I think I agree with everything both of you guys just said, and I think today, 2016, it's all about batteries are a solution. It's not people wake up and say, okay, I love batteries like I love solar or wind. Batteries are a solution to a very specific problem. And sometimes it's demand charge management for behind-the-meter customers. Sometimes it's replacing songs and peaker plants. Sometimes it's voltage and frequency regulation or avoiding transmission and distribution build-outs for a couple of years. But I think if you look ahead 5, 10, 15 years, I think 90% of energy storage is going to be used to basically solve the problem that a massive deployment of intermittent renewables creates, which is, in California, we have a renewable portfolio standard that says by 2030, 50% of our energy needs to come from renewables. Most of that people think is going to come from solar and wind, which is intermittent. And if you look at the numbers just for the US grid today, there's about 1,000 gigawatts of power generation capacity, peak power generation capacity, and only about 27 or 30 gigawatts of solar installed. So that's about 3%, but it's only running when the sun is shining, so it's around 1% or so of our energy comes from solar. But depending on the administration and incentives and policy, et cetera, people have been thinking that by 2020 we could go from 30 gigawatts of solar to maybe 90 or even 100 gigawatts, and by 2020, by 2030 that could be 300 gigawatts or more. And the higher you get, at a certain point, you need to time shift, like you were saying in your initial example with I guess it wasn't TiVo, maybe it was TiVo in your beginning. You need to time shift multiple hours of tens of gigawatt hours of solar energy to the morning, evening periods. And really, there's lots of ways you can try to change the demand curve with time of use pricing and demand response and other sorts of things, curtailment. But if you really want to use all that solar, you're going to have to store it, and you're going to need tens of gigawatts of energy storage. And right now, there's maybe a gigawatt out there, and you're going to need to have, by 2030, 70 gigawatts. And it's really the answer, which I think most people don't appreciate. It's the answer to renewables. Everyone understands renewable deployment. They don't understand that you need to exquisitely balance load with energy generated every moment, and you need batteries to do that.
I would also suggest that solar scares the heck out of utilities because they don't have the control and visibility that you mentioned, whereas storage, they inherently have to have that, they are going to have that visibility, and it's a friend to utilities rather than a threat to utilities.
So who, not to get economics on us, but who pays for that? Like, who pays for that storage capacity? Where is that? Is that a government function? Is it a utility function? Is it a private function? How does that work?
You won't pay for that.
Yeah, sure. Okay, fair enough.
Well, it's a great question. Batteries are really expensive. And to put in large batteries, those are large construction projects, which is really expensive, especially if you have to use unions, even more expensive.
Yeah.
You need multiple revenue streams to be able to pay for it. So as I previously described, there's multiple uses for the battery. The utility gets to use it some, the host customer gets to use it some, the grid gets to use it some. If all of those provide a payment that is normalized among the group, you can stand up a battery project. But today, it's an expensive technology, and it's difficult for certain utilities to justify in mass application.
But nevertheless, if it's a rate-based asset, it's being paid for by
The
us,
ratepayers.
right?
Yep.
Ratepayers.
Yep.
Yeah, I mean, that sounds like an awful lot of coordination
Yeah.
happening for what I
Yeah.
see out in the marketplace,
Yeah.
right? So let's get into the batteries themselves a little bit. I just want to make sure we get into that. I guess ripped from the headlines, right? The first thing that I talk about with people whenever we get into this is what we see happening in the battery world with safety, right? So we've seen, 2.5 million Galaxy Note 7s recalled, and we've seen Dreamliners with problems, and we've seen hoverboards with problems, and all of these issues coming up. And it just seems like it's been in the news a lot over the last several years. So I guess my question is this just an inherent problem in the technology? Is it something that can be done? How do we think about the safety problem? I mean, Qichao, you're in the middle of this.
I think if you look at battery, just fundamentally, especially as we just want higher and higher energy density, you go from lead acid to nickel cadmium to now more and more advanced lithium ion. The higher the energy density you get, actually, the more dangerous it becomes, because battery, just fundamentally, it's actually quite similar to a bomb, right? well, so if you look at bomb,
my cell phone out now.
really, it's like a chemical reaction between two materials, but a battery is an electrochemical reaction, and then you prevent that by putting a membrane in the middle. So a lot of the safety actions that we have seen in the industry, some of it is just from manufacturing, and I think a lot of the big companies have become very good at manufacturing. Panasonic, LG Chem, these guys have not had an accident in 10 years, and that's quite impressive. But also just fundamentally, even in the design, for example, in the case of the Samsung Galaxy 7, really is just Samsung really tries to compete with Apple for the high-end market, and then a couple other Chinese cell phone makers for the low-end markets. So they really try to compete, and then and they try to make this membrane that blocks the two materials called separated as thin as possible, and just really aggressive, trying to push for very high energy density, fast charge, because people want long-lasting cell phones, fast charge, and it's not really a manufacturing defect, it's just fundamental design. They made this membrane too thin. So I think the lithium-ion technology today, especially now that for a lot of the applications, people want high energy density, but they don't realize when you want high energy density, you want a more explosive bomb. And it's unless we switch to a completely different technology, this is just an inherent problem.
So I guess what I'm hearing you say is you can do something about it, but the thing you have to do about it is make a less effective battery.
So if the technology stays the same, if we use lithium ion, to make the battery safer is to use a less advanced battery. For example, the Toyota Prius still uses a lot of the nickel metal hydride, not lithium ion. It's less advanced, but it's safer. The other way to improve the safety is to go to a completely different system. Solid state, some people have developed other materials that are just inherently safer.
Okay.
So you can improve both the safety and the energy density.
Well, just reading about it, right? The way I hear it is that lithium ion is basically the bet that everybody's making for 10 or 15 years in the future. So it sounds like this technology is here to stay for a while. I mean, obviously there's a big factory going up in Nevada that's based on this thing. So you talk about these other things that are safer, and I've read about other technologies that are maybe better performance. But is that realistic in our economy, or what's going to happen? I
mean, I think if you look at the mass market, cell phones and cars, so large lithium-ion companies, you can count on 5% to 7% improvement in energy density and other performances every year. That's something that you can rely on. And then car companies, cell phone companies, when they design their next product, they take that into consideration because that's something that you can really rely on. People say there is no Moore's law, but then these large companies, they've done a just incredible job. If you look at the Tesla, they use this little 18650 can cell. When it first came out in the early 2000s, this can is about 2.4, 2.6 amp hour. Today it's about 3.6. So that's just really good engineering and also some materials improvement. But I think there are some applications out there, especially when it goes to really small or really big. That's where some of the new technology may become more usable. And also, a lot of the technology out there, I mean, we still have noise, right? You hear some researcher in some university lab, they holding up like a vial of 10 grams of powder and say, he's going to build a car that goes 500 miles. So
he's not going to do that?
I don't think so. At least not in the next 5 years. So
Little car.
there is a lot of noise, but then there is a lot of good stuff. And as long as if these research labs or companies, if they can demonstrate the new technology in a form factor that can be tested, like in an 18650 can cell or in a larger pouch cell that can be tested and can be dropped into an existing phone or a car, then that is meaningful. And then all these big car companies and large cell manufacturers, especially now they've seen what Tesla and Panasonic are doing with the Gigafactory. LG Chem is trying to build also a large Gigafactory with another car company. SDI is doing it. And they're all trying to leapfrog each other. And engineering, infrastructure, they're kind of similar. So the only way to leapfrog their competitor is to look at new materials, new technologies.
There's the language that you're using, though, you keep talking about this breakthrough in batteries. And
Yeah.
I would suggest that whereas when a venture capitalist looks at an optical networking company, they want to see 10x improvement in performance. They want to, in a not that VCs invest in semiconductors anymore, but if they were investing in semiconductors, they'd be looking for a 5x, a 10x improvement. Whereas in batteries, I think, you mentioned, we're talking about arithmetic incremental improvements in performance, and if you can offer 1.2x performance, I think in a battery, that's something that a VC would be willing to talk about. I guess it's the best you can do within batteries, but in terms of a breakthrough, you'll get a really good bomb, right? Yeah. I mean, we keep talking about this bomb. You can get a really volatile thing, but getting something that you can commercialize. So I don't think there is this in the electrochemistries. I don't think you're going to ever see this it's hard to envision the black swan that will happen with a safe electrochemistry.
If I can just add to that, so if you look at battery, a battery is a really trick device. You've got about 5 parameters that people care about: energy density, power density, cost, cycle life, and safety. And for big companies, they can make 5% to 7% improvement on everything, and that's a solid improvement, even though it's incremental. Some of these so-called breakthroughs, they basically jack up one of those parameters, 5x higher energy density, but then everything else is like 20%. So then it's misleading. It's not real breakthrough.
So Mark, is that how you think about it? I mean, are those kind of improvements acceptable to the venture community?
Yeah, I mean, I agree. It's tough investing in the battery industry as a venture capital firm. I'd say solar in the clean tech sectors or subsectors, solar's kind of been around the longest in terms of most venture capital firms and dollars going into it. I'd say energy storage is the second longest. Mm-hmm. Every venture capital firm who has done any investing in clean tech has invested in at least one battery company, and
burned.
Yeah, I mean, you think, most venture capital firms like ours don't like to actually take on technology risk. They want that. There's a handful that will go early stage and will take on science projects, but most of them want the science to be done, and then it's a matter of building out the team and the product, et cetera. And I think either wittingly or unwittingly, when you make a venture capital investment in a battery company, you are taking on technology risk because it's electrochemistry, and it's not as easy as semiconductors and Moore's law and making those advances. And you pull on one end of the of the string and some other part unravels in terms of the 5 areas you talked about. In terms of, is it all lithium ion and that's for the future? I think that's generally true for cars, cell phones, and laptops, because lithium ion just has this great combination of the power density and the volume and the weight and the application that it's being asked to do. The problem that it's solving is not full depth of discharge on a daily basis for many hours. And so when you talk about the grid, and as I was talking earlier, shifting 5-6 hours of sun energy to the morning and the evening, and if you want to do that every day with 80% plus depth of discharge, lithium-ion batteries, at least today, are going to run out on you. And other sorts of batteries, particularly flow batteries, which are super heavy and super big, and all those other parts, but they sit on the ground. They're not, you don't have to move them on wheels and have an impact on how far you can go based on the battery. You don't have to put it in your pocket. Right. And because you don't have to make those sorts of, you don't need to have performance in that areas, you can maximize performance in other areas. So I think there is an opportunity for flow batteries. The problem is they have to fight against the cost curve that lithium-ion batteries, which might be an inherently inferior battery chemistry or battery type for shifting hours of storage from one part of the day to another. It might be inherently inferior, but they're just so far down the cost curve that it's really hard for flow battery companies to finance their way through negative margins initially to zero margins to positive margins to get there.
So those types of batteries might work in some of the use cases that Katerine was talking about.
Yeah.
Right?
Yeah, for
where
grid.
it's a different,
Grid.
different story. So if you do come up with another technology, a breakthrough technology, do you have to blow up all the manufacturing gains that we've gotten? Because what I keep hearing is we have all these great manufacturing gains. We've gotten really efficient and really good at pushing these things out. New technology blows all that up, we start over, or how does that kind of work with that world?
I mean, I think if we were back in 2007, 2008, and you have a new breakthrough, then it's very easy to get capital to build infrastructure. But unfortunately, investors and the market has gotten a lot smarter than that.
So we need dumb investors.
So I think if it's worthwhile, the battery users, the battery cell manufacturers, they would prefer if you can just marginally tune their existing infrastructure to build this new battery. That would be ideal. So it'll be a drop-in replacement, and then so they wouldn't have to change this $100 million line and then just build battery. It's still the same line. They probably have to tune it up a little bit. But if there is just an entirely new technology that requires, for example, completely different manufacturing process, say using semiconductor process to build batteries, if that is real, then it's worthwhile to do that. But so far, we've seen a lot of so-called all-solid-state batteries that are built using semiconductor processes, but they are like 50 milliamp hour, tiny batteries. It's not real, and therefore it's just not worthwhile to make that investment.
So I've been hearing that the Asia-Pac companies are 5 years ahead, 10 years ahead of US in terms of manufacturing and doing that sort of stuff. If we have a technology breakthrough, something new, does that give us a chance to leapfrog, or does that mean that they're just going to do that one better too? How do we think about manufacturing and innovation in the labs and then getting it out to commercial?
I mean,
Eric, go ahead.
I'll jump in. I have a lot of reservations about what St. Elon Musk is doing these days with his business, but I trust him from a technological due diligence standpoint, and him and his brain trust decided that lithium ion was the way to go for the gigafactory, convinced some financiers as well, and convinced staid Japanese conglomerates to make the investment as well. So it would, if he has the best battery minds under his roof making decisions about future technologies, I'd have to, I don't know about the Tesla Solar City merger, but I think I'd go with him on lithium ion.
I'd have to add, and I'm a commercial person, I'm not a technology person, but you have to invent the technology, and it's great if it's a breakthrough, and then you have to commercialize the technology.
Yeah.
And a lot of inventors and more technical people say, look, I've created this great thing, and I would say, okay, how do you bring this to market? Because if you don't have a market for it, it ain't happening. So what Tesla created, in addition to their chosen chemistry and how they approach technology, they created a brand. So for anyone to enter a market to compete with, no matter what your chemistry or technology is, you're competing with existing brand. So we, AMS, does not create our own batteries. We're currently using Tesla power packs. We're a technology agnostic developer. When we won our utility contracts, we had a massive request for proposal from vendors. And everyone from around the world responded to our RFP. That particular RFP, which took place 2 years ago now, and there's been a lot of innovation since, Tesla won head and shoulders above everybody on functionality and on price. And then we went out to our large customers, which is the big box stores, the universities, the commercial real estate guys, and we said, okay, of everyone that's out there, who will you allow on your site? And 99% of them said Tesla, because that's something they wanted to show off, in addition to the financial gains that they would get from energy savings. They liked the Tesla brand. Tesla also had years of performance, field performance experience that we could go to our financing partners with, whereas a science experiment will not work in commercial applications today.
And I think just going back to battery manufacturing, it's really hard to do that in the US. A123 tried it, N1 tried it, Johnson Control tried it, because it comes down to ecosystem. If you look at the 6 of the biggest lithium-ion manufacturing companies in the world, 2 are in Japan, 2 are in Korea, 2 are in China. And even with Tesla, A123, when they started, they hired a whole bunch of engineers from Korea, China, to the US. And then other companies, Apple, GM, when they hired their engineers, they did the same thing. It's really hard to do that, especially for mass markets, cars and cell phones, because there just isn't that ecosystem, the talent, the material suppliers, component suppliers. I mean, we were trying to build these little 18 amp-hour cells. All the tabs, pouch materials, we couldn't buy them in the US. You had to source them from Japan, from Korea, from China. So it's that entire ecosystem. But where US is really strong is in technology development at national labs, universities. I think companies need to bridge this gap, like Katerine mentioned, just taking this technology from national lab and then convincing a large cell manufacturer to build it, to make it real. There still are a couple cell manufacturers in the US for some niche markets, space, defense, some medical applications. Also, the US is quite strong in primary batteries like Energizer, Duracells, but just when it comes to rechargeable lithium-ion for mass market, it's really hard.
Okay. Just really just kind of getting to the end here, because I want to make sure we have lots of time for the folks in the audience. But we talked a little bit about costs, and my understanding, layman's understanding of the cost curve is that it's getting to the point where on the horizon where this stuff is going to be cheaper, and it's going to make less and less sense for me to drive a gas-powered car, and it's going to make less and less sense for me to use these other sources. What's your perspective, any of you? What's the perspective on where we are in that horizon, and then what happens when we go over the threshold?
So we were talking a little bit, and I've written about it. There's a bogey that says that $100 per kilowatt hour for an automotive battery is sort of some golden threshold.
Magic number, yeah.
Equilibrium is just the point you pass through, right? There's not some trumpets that go off when you hit that number. But there is a crossover point where, like you said, it makes the most expensive piece of that bolt, that Chevy Bolt, a lot cheaper, and all of a sudden the Chevy Bolt is now $15,000 with tax credits instead of $25,000, and it becomes a no-brainer to buy, as long as you've answered the mirage of range anxiety, as long as you've dealt with the false idea of range anxiety.
Why do you say mirage?
Because this is not original reporting here, but I'm afraid to drive my Jeep up to Tahoe because I may not have enough power in it. How often do you drive your Jeep up to Tahoe? Oh, once every 10 years, right? And so it's not a realistic thing. People drive an average of 50 miles a day, and that will be satisfied by most any hybrid or EV, or any just BEV that's out there now. So that, I think that's, when I say mirage of range power, that's the imagined trip you're never going to make is scaring you.
Anyone else on this one? I just want to make sure that we think about this because it's sort of held out there as the trumpets, right? The big event. Now all of a sudden everything's going to change because we hit this threshold.
I think I saw an article somewhere that was saying that basically the cost parity, the equilibrium point for, this is gross generalizations for gasoline-powered cars versus electric battery-driven cars was about $1 a gallon gas. In terms of the marginal cost, the variable cost of continuing to run it. That doesn't take into account the $90,000 you paid for the car, right? If it's a Model S, to have as a bigger range as possible with the kind of size of the battery you need. But in terms of the energy cost of the electricity for that battery, for what you get from it in terms of the mileage compared to a gas-driven car. And even though gas prices are down now, I think it's, that's below basically the refinement and the gas tax level. We're not going to see $1. You can't profitably refine gasoline for, less than $1.
Yep.
And then you add in the tax that we currently have, if you take that away. And, so it's basically, there's no turning back. If people can get over the range anxiety and we can get the price of cars down from, $100,000 to $60,000 to $30,000 for all the stuff around it, including the battery pack itself, which is the largest.
Every large car company is investing in electric cars.
Yeah.
It is clearly the future. It has to do with reprogramming consumer brains. And I have an EV now, so I don't know if that's an early adopter or in time. But I think of it as I came out of the finance industry and I was really used to using a BlackBerry. And everybody was already on the iPhone, and they said, why don't you have an iPhone? And I said, I'm so used to punching the buttons, I need to punch with purpose. And they said, you should try the iPhone, it's pretty cool. And obviously, I do not have a BlackBerry currently, and it was pretty cool. But you have to reprogram yourself to think in a different way.
By the way, something I just learned recently about transportation is that what's driving the automotive battery industry is nothing to do in the United States. It's Chinese buses that is driving the EV bus industry and the EV battery industry. So China can mandate that all million of their buses have to be battery powered, and the same transformation of the solar industry going from $10 per watt for a solar panel to 28 cents per watt for a solar panel, that kind of transformation could happen with batteries driven by, forget about phones or luxury vehicles, but by mass transport in Asia.
Yeah, and also if you look at the Chinese market, so today the latest number that I've heard is the batteries for the e-buses is around 40 to 50 US dollars per kilowatt hour. So it's significantly lower. Wow. I'm not sure if you can, so you certainly cannot use that for cell phones and laptops because it's a iron phosphate-based chemistry. But there is just a strong push by the government because it's not about clean tech, just they've got this pollution problem. And if they don't do something about it, then that is a big problem. And also the consumers, not just the buses, but also the passenger cars, they don't have this love affair that Americans do with gasoline cars. They don't have to drive to Lake Tahoe. Yeah. And it's, for a lot of them, their first car is this electric car. If it's 40, 50 miles, then it's plenty.
Yeah. Okay. Thank you all. I want to make sure that we have time for the audience. There's some folks around with microphones. Please flag them down if you have questions for our panelists, and let's open it up.
Kevin, I really like the analogy about the VCR to streaming. I'd like you all to consider a different analogy, which is the personal computer when we got rid of bend, fold, don't bend, fold, spindle, or mutilate punch cards, and we all got our personal computers and then our servers, and now we're all back in the cloud. And so how do you think this will play out with storage? Will it be distributed at the grid edge, or will it all be centralized again?
Who wants to take it?
Well, I'll jump in. I mean, I think one of the reasons why Tesla bought Solar City is they think that it is going to be distributed, and that there'll be for at least for a large percentage of the homes, they'll have solar on the roof and a battery, and they've been off and on getting into energy efficiency, and they'll get into smart water heaters and demand response, and kind of try to do as much as you can in a distributed fashion at the home or at the business of the industry, and then for the cost saving benefits, and I think it'll help take some of the pain off of having all the renewables being integrated. If you can sell, what we were talking about earlier, if someone just goes out and willy-nilly puts 100 gigawatts of storage out in the desert and then just wires it into the grid with no PV into the desert with no storage attached, that creates a problem. But if you're doing one with each in the same exact location, you kind of avoid that problem.
But right now, battery backup, which is the application that people think of first when they think of their home battery, makes no sense with a battery. It makes sense to do with a little Honda generator, right? I have a friend who builds houses for really wealthy people in Aspen, Colorado, and when they want to put backup power to their house, they build a bunker and they put in internal combustion engines, generators, that run underground, and that's when the power goes out, the wealthy house is now powered by a 50 kilowatt gas generator. They don't use batteries. So right now, there isn't a rationale for distributing battery power. From a commercial standpoint, and what AMS is doing, it makes an enormous amount of economical sense as long as the current regulatory construct stays the same. What worries me about AMS is that, and despite your CEO being the utility whisperer, right? Worries? No, I mean that's what she's been called that. And yeah, well, anyway, but if the regulatory situation changes, the business plan is hollowed out to a certain extent, and that's worrisome. So when and if you go public and your list of risks, the major risk is a regulatory. What happens if some socialist becomes head of the CPUC and decides that these monopolies, anyway, makes a major change in time of use pricing or some type of pricing, it hollows out the business plan. And so it's not there's no.
Or it improves it.
Or it improves it.
I mean, you take away net metering and you jack up time of use pricing, and then that's a real big use case for storage.
But the thing to be aware of when batteries is there's liars out there, and there's also, we're very, very bound by monopolistic regulatory constructs.
Yeah, so we're obviously a grid edge company, a distributed company, but I actually think that there's a role for both. And I think it's a question of emissions. If you can have a central power plant that is emission-free, that can ramp up and down quickly, that can serve the needs of a grid, that's a really nice solution. Central station solar doesn't accomplish that on its own. It works when the sun is shining, and then it doesn't when it's not. But maybe a solar facility like that, paired with a large battery, can now displace the alternative and become that central solution. So it's probably a combination of both in the future.
Next question.
Hi, I'm Charlie Vogelheim from Motor Trend, kind of automotive related. Can you just speak to the sourcing for the lithium, for the current technologies in batteries right now, both, again, sourcing and then disposing of the materials, and how that fits into a green environment?
Is anybody an expert on that?
So when you say sourcing, are you asking where does Tesla get its batteries, or you're talking about where does Panasonic get its cobalt, its lithium, and the materials that go into the battery itself?
Just as we talk about electrification from a worldwide sourcing standpoint, whether it's the buses in China to the Teslas we drive here in California, just, you know, again, from the mining operations to the locations, and then, of course, the disposal at end of life. And you could even add in, you know, again, in terms of how quickly end of life occurs.
Yeah, that's a great question.
Yep. So if you look at a lot of the large battery companies like STI, ATL, they recently built their new factories in China very close to lithium mines because originally the mining of lithium carbonate, which is a precursor used for cathode, lithium salt, all these materials, it was quite limited. But now there is this demand, a lot of these large so-called gigafactories, not just the Panasonic one in Nevada, but also Samsung, LG Chem, their gigafactories are very close to lithium mines, and they want to be as vertically integrated as possible. And then in terms of second life, what we've seen a lot is that typically after 8 years, so you put this battery in a car, after 8 years, you will have a second application for it, for storage, for other applications.
But if EV penetration goes up like optimists are predicting, there's going to be pressure on lithium, cobalt supplies, right? And there are some startups that have tried to find alternate ways of getting lithium out of brine from geothermal wells or something like that. And so I would suggest that as the demand for these constituent chemistries the elements go up, we're going to find smarter ways of people are going to find ways to drive down the costs and find. It's also going to, the demand for it is going to open up new ways of extracting it from mines or brine pools. That's one of the sources, right? Yeah. The other thing to consider in terms of disposability is that after the car battery has ceased being practical, you can take that battery and use it in a less critical application, whether it be for you, right? It could be, you don't need that same type of cycling capability. So you can take and there's a lot of work being done to take those old car batteries and repurpose them with grid scale batteries.
Other question?
So President-elect Trump has expressed some skepticism about the importance of climate change, but he's also apparently talking about $1 trillion of infrastructure investment. Is he going to wind up being a friend or a foe of the battery industry?
I like to say that you can't put the genie back in the bottle. So it's here. And it's not just driven by politics and regulation. It's also driven by astute energy users and technological innovation. And we continue we think it's going to keep giving rise and scale to the industry. Now, are we expecting tax credits from the administration for batteries? We're not holding our breath. But we do think that there's a big market ahead of us for batteries.
So there is a tax credit that's applicable to solar and to batteries,
that's right?
It's so small and it's already going that it may be too small a target for that to be trimmed by the new administration.
You mean the ITC?
The ITC, yeah.
But they're talking about doing it for solar standalone storage, right?
Yes, and there's even the FERC has passed some very positive things. But it's just, I don't want to give you a doom scenario. It's easy to find one, but the possible people that the Trump administration are talking about for the Secretary of Energy includes Harold Hamm, who is a wildcatter fracking billionaire, right? Also, the Nuge is being considered as a potential Department of Energy secretary.
Yeah. But they're going to have to go to some of the most progressive power users, like Walmart, and say, hey, Walmart, you're no longer going to do solar, and I'm not going to do storage, and you're not going to do fuel cell. I don't think that's going to happen.
The Nuge is Ted Nugent, by the way.
Yeah.
I'd also jump in briefly on that. There's national policy and its effect, and there's state policy. And right now, I think there's 29 states that have renewable portfolio standards, like California's binding RPS standard of achieving 50% of the energy use in California by 2030. So 29 states have those sorts of obligations, which means they're going to need deploy solar wind to do it. And if you believe they need to shift that energy in order to make full use of it, then they're going to need the storage. And you may not get a helping hand from national government on that, but you're going to have that problem.
But if he
doesn't
were to
solve that
gut
problem.
the ITC, if he were to take away all subsidies, he would set back the industry by a few years if you're going to consider that that 30% decrease would be made up eventually by price decreases.
Yeah, that's
in the
true.
industry, right?
But I would say that nobody knows, but the current scuttlebutt is that it doesn't seem like there's a lot of political will to roll that back. There's much more political will from the administration and the Republicans to just make it easier to do fracking, remove regulations on coal and natural gas.
Okay, who's next?
It was deep breathing.
Yeah, I'd like to direct my question to Mr. Hu, and I'm Gene Payed. I'd like to know your thoughts on this. Can a manufacturer on electric cars use two batteries? Like, you're using the first battery for 400 miles, then while you're using it, it's charging the second battery. So when you go to Tahoe, once you use the 400 miles, the second battery will kick in for another 400 miles and back. So that means you could go an extra mile for more distance. Is that possible? Or they are withholding this technology?
Well, I think the problem is that when you're not using the second battery, it's just dead weight. And I mean, a lot of EVs, they do use two batteries. They use a big battery and the tiny small one to heat up the battery when it's cold, but they typically do not have two similar sized batteries because if you're not using the other one, it's just dead weight.
Maybe you can get one of those underground, generators. You just carry it around.
I think the answer is no.
Yeah.
Yep. Harish Kamath from EPRI. Eric.
Hi.
We have been spending the last 15 years throwing rocks at the battery industry together. And I'm going to ask a strange question. Is it time for us to stop? Because, I mean, the panel's been talking about breakthroughs. But let's take a look at what's really happening here. You know, Katerine's company is buying multi-megawatt batteries from a company that's basically building multi-megawatt batteries for peaker replacement on a cell that was developed 30 years ago for camcorders. I mean, you could argue the breakthrough has already happened. There's nothing new that needs to be done. They're already doing it. It's an application problem and not a technology problem. So, I mean, as you said, we shouldn't expect, there to be fanfares, trumpets, angels coming down, whatever. We should just expect a gradual increase of usage of these technologies and those kind of applications. And I'm open to any other comments from the rest of the panel as well.
Well, this is certainly an honest battery expert, by the way. I think the only point I was making is that there is no black swan, and that there is I get a lot of noise from my funnel of people yelling at me about the next breakthrough. You've probably had to live through that as well, right? All these new technologies that don't pan out, or that somebody's demonstrating on something 1 millimeter by 1 millimeter that can't be scaled. So please don't stop what you're doing at EPRI, but I think looking for that 2x breakthrough, even if you're a scientist, I think that this is just magical thinking. But what we're seeing in solar is a good example of what we might see in energy storage. That parallel works.
In terms of the cost.
Yeah,
On cost. And also on horrible attrition in VC-funded startups as well.
Well,
And I'm sure you'll cover it.
Yeah.
And I'll
Greentech
cover it,
Media.
yes, I will cover that.
Since you mentioned our company, you're absolutely right. There's nothing new about the cells that we're using in the Tesla batteries. Nothing new. That's what our investors like, and that's what our customers like. But innovation doesn't just come in technology. What we've created is a very innovative business model. We found an application for these batteries that has never been done before. And that's what bringing the scale
I
to
think
market.
a company like ours that has this value add in the business plan can be a potentially 30% margin, 40% margin company, whereas a pure hardware battery play is a 5% EBITDA forever. Why bother getting venture capital funding for that company?
Well, you might get bought by Tesla.
You might get bought by Tesla.
Right.
Yeah, because Tesla is on the look for tweaks, right? And they have to be conservative because they have to sell to customers like AMS, and AMS needs bankability for their project investors. But now I can guarantee that Tesla's looking at more silicon in the anodes, and probably looking at your company in terms of the lithium metal technology and other tweaks. You know, they've dabbled in lithium ferrous phosphate, and they've kind of pulled back on that a little bit. They do. They haven't done LFP, but other folks like Sonnen and Enphase are doing LFP, lithium ferrous phosphate, so they should be taking a look at that as well. So I think that there's so many different variants on. I mean, I'm talking in your direction, but you kind of wrote the report on all this, so I feel a little sheepish about it. But there's so many different variants on lithium, and tweaking knobs and little tweaks and adding in different components and elements is what Tesla is very much interested in doing.
And also, I think, yes, there is a lot of noise, but then it is about time that we're about to see a major breakthrough in not just technology. I'm talking about product. The 18650 cell that Tesla uses has silicon, and that was a breakthrough that came out in the late 2000s, and that got implemented at scale. And typically, and today, if you talk to a lot of these cell manufacturers, they are in stealth mode implementing process lines, pilot scale lines for this next type of anode and also cathode that will go into a cell in 2019 and 2020. So yes, there is a lot of noise, but then because there's just a lot of applications, demand for EVs, demand for longer lasting cell phones, safer cell phones, smaller watch, and also a lot of new applications like high altitude solar planes, drones. This has driven just a lot of technology development. So when you see a lot of noise, that means there's a lot of stuff in the pipe, and we are very close to a big breakthrough at the product level.
Heard it here first.
There's a question here.
Hi, Jim Reed, and the answer you gave to the question perfectly lead into my question. So we're all talking about electric vehicles riding around. I've seen a lot of things in the social media lately picking up pace about electric aerial vehicles, VTOLs, 1-2-person taxis. I think Uber has a concept. I'm hearing a lot from Airbus, and remarkably, they're saying in 5 years we're going to have these. So is there some magical world to tennis? I mean, I'm thinking, I used to be in the aerospace industry. You know, if you want to get off the ground, you have a weight problem, not only an energy density problem. I'm seeing you've got to have 100-fold increase, or maybe I'm missing something. What is the big breakthrough that these companies see that are going to happen? Because they're saying in 5 years you're going to have electric-powered, propeller-driven planes.
According to Musk, I hate beginning the sentence with that, but if you get to 400 watt-hours per kilogram, you are now able to start doing electric flight. That is the number. So I'm sure there's a napkin somewhere that has that calculation.
I knew we'd come back to Iron Man suits by the end.
You know, that's before the Iron Man suits.
Yeah.
So I don't think it is. I've reported on this. I haven't done the calculations, but that number, 400, which is achievable in the next couple of years, I think on a commercial basis, is the get that load off the ground number.
So traffic problems, everybody's going.
Well, so for unmanned, it's like 400 watts per kg. For manned, like a passenger Boeing 737 or an Airbus 380, that's impossible to fly that just pure electric. Hybrid maybe, and the number there is 550 to 600. So that is, it is possible actually, but that is about 5 years out. But the 400, we have already seen a lot of that in companies, not lab scale tiny materials, like real cells. Yeah. So it is possible. Yeah.
Anyone else?
Hello?
Double. The gigafactory is supposed to double the production output of lithium cells. What happens to the cost of each doubling?
What happens to the cost of lithium cells each time we double the annual production?
I don't think there's an economy of scale when you go from 1 gigawatt to 2 gigawatts. There's manufacturing efficiencies, but I don't think there's any. Dick Swanson's law, which isn't a law, says that for every time you double solar panel manufacturing, you lower the cost 20%. But that's not really a law. That's just sort of an observation, right? It's not a rule. Maybe there's a similar effect, but I don't think going from 1 to 5 gigawatts gives you a formula to lower the cost of that battery.
Why do it? Why do a gigafactory? What's the point?
So why do I do it? Well, going from 100 megawatts to a gigawatt?
Why would you just do a whole bunch of little things? Why take that huge risk and build this massive?
So let's check back in 3 years, I guess, and see how that works out.
So we're learning, we get a learning of 5% improvement per year. What's the doubling? How long does it take to double the production capacity? Is it 3 years, 5 years? Solar's running about 3 years. Any of you guys know?
I don't know.
I don't know.
Probably understand.
I mean, that would tell you, right? I would give you an indicator.
I will say that the Tesla Gigafactory is certainly not the only Gigafactory that's going up in the world.
We're going to see multiple doublings over the next 5 years on battery production, which in solar led to going from $18 a watt to 28 cents a watt, right?
Yep.
But we're not going to see any change in costs for batteries.
I don't know.
Okay.
I think the costs will go down. I think we just don't know how much. I mean, I think part of what Elon is doing is the vertical integration, so he doesn't feel beholden to the battery suppliers like Panasonic, like he is now. And he can kind of have a competitor, which is his own in-house capability of making the batteries. But he may end up, I'm not sure he knows what the exact cost will be at each stage of the scale up. He just knows that he can use it as a threat in negotiations against Panasonic. When he buys
One of the
batteries.
drivers for cost reduction in solar was illegal dumping of below cost solar panels, so we can experience that same illegal dumping of low cost lithium ion batteries that will serve to lower costs as well.
So
We're looking forward to it.
It's true.
So we just have time for a couple more. Folks with the microphones?
This man was skipped over.
Yeah.
Twice.
Wait for the microphone.
Wait for the microphone, please.
Being loud enough, but is there any movement in the automotive industry towards swappable battery modules which might address the range problem or range issue, the perceived range issue?
What was the
In
question?
other words, you pull into a gas
Swappable
station, you swap the battery rather than
Sure.
charge it.
Well, that was tried, right?
Yeah,
and
better
cost
price.
several $100 million of dumb money, or anyway, for a company called Better Place, right? It received hundreds of, maybe $500 million to do that exact battery swapping thing that you're talking about. You drive to a gas station, your battery pack gets automatically removed. Another one, fresh one, gets put in. You don't have to wait an hour to do the full charge, and you're off on your way. And it's just it would work on an island, or in Israel, which is essentially an island, or in a small country like Sweden, where they tried to do it. There might be some ways to do it, and even I think Tesla actually has that, or he's claimed he has that option to actually do that swap. There's a video showing that somewhere, but I don't think that's the way to go.
Cost manufacturers for standardized battery?
That's exactly what you'd have to do. You'd have to get every manufacturer to agree on a form factor, and the only one who agreed it with Better Place was Renault.
I think one of the problems, just thinking about it from the Tesla standpoint, is if you drive your car to deep levels of discharge on a very regular basis, you're going to degrade your battery pack. Potentially, if you did that on a daily basis, in like 3 or 4 years instead of the 10-year life. And then if you kind of did that, and then for almost 3 years, really degraded its ability to recharge to a certain level, and then went and did a swap, then whoever ends up with your battery is kind of with a lemon battery once I think it's recharged, and then you're kind of happy because you got a battery that presumably wasn't driven as hard and isn't degraded as much. So I think there's that kind of, I think people who own the cars themselves are very protective about the batteries, and that's one of the reasons why they're not particularly excited about allowing the utility to pay them, 10 or 15 kilowatt cents an hour to just discharge their battery while it's plugged in at home to help out with grid management, because that's just going to add more cycles and more degradation.
Sure, your 66 Mustang, we're going to take it in, we're going to swap the engine and send you on your way, right? You're attached to that engine. You don't want to give that up.
I think it might work not for people who are owner-operators of their cars, but people who are leasing cars or for fleets.
Yeah.
Fleets.
And that's where, and I think we definitely could see a great application in that for fleets, UPS trucks, stuff like that.
Totally.
Where they're out there driving for 12 hours and they can't make it 12 hours.
Or bus fleets,
Yeah,
something like that.
Over here.
My name is Ken Kirshner. I'm interested in each of the panel's comments on research that's in progress, both academic and commercial research, and if you could suggest some areas that you're personally tracking that you might be interested in and sharing that with everyone.
I think the two paths, one is safety and one is energy density. So in terms of safety, there's a lot of work around solid-state batteries. Today, they still haven't solved the scalability issue of these batteries. These batteries still remain tiny, tiny batteries, or batteries that only operate at high temperatures. But there is some work being done both by national labs as well as companies like Toyota that have pushed that boundary and they made a lot of really exciting progress. And then in terms of energy density, silicon now is already being used in mass market, cell phones, cars. One approach is to improve the concentration of silicon to get to higher energy density. And another is basically the holy grail, which is just making lithium metal work. Because lithium metal, if you look at the periodic table, is the lightest metal. So if anyone can make that work safely and reliably, then that is huge.
From the venture capital funded world, there are a number of startups you're probably aware of, whether they be Ambry or QuantumScape or Aquion. These are not lithium ion, but they're electrochemical formulations, and they are in pilot production. And there's a lot, a company, SAC-D3, was sold to Dyson, the vacuum company. But in most of these, I would refer back to the previous Edison quote.
We're looking a lot into the various software and analytics platforms that go together with batteries for commercial and industrial applications.
And then we maintain relationships with the national labs, NREL, and some of the universities, but it's really not actionable for us given our particular venture fund's approach of not taking on science projects and that kind of technology risk, because they have that tiny battery that isn't fully at the performance specs, and it just gets us distracted from the companies that are further along, either in energy storage or other areas, if we focus too much on what's the hot stuff that researchers are working on. There are some venture capital firms that go super early and then will, invest in a Yetman Chang, an A123, or a SAC-D, or one of the Don Sadoway ones super early, but that's not us.
Great, thank you. Last question.
Hello,
Hi.
my name is Allison, and I work for the Center for Sustainable Energy, educating about electric vehicles. And I have two questions. One's a much bigger one that somebody already kind of touched on, but I think deserves a lot more attention, and a more simple one. So the simpler one, Qichao, you were talking about that lithium-ion batteries are inherently dangerous. And the more energy you pack into them, the more dangerous it becomes. And people want a really long-range car. So I'm curious, what do you think the maximum range is until you start to become more and more dangerous and it's not worth it to pack more energy into that car? And then my other question is about the lithium mining and manufacturing of the batteries. For clean energy and sustainability, we want our solutions to be cleaner and more responsible than fossil fuels. But what if these batteries in the long run are more dirty and more dangerous than fossil fuels? So I'm curious if you guys know more about the entire mining and manufacturing process. And it's great that electric vehicle batteries can be used for stationary energy storage after their vehicle use, but then what about after that? Then they still have to be disposed of after that. So looking at long-term, the entire life cycle analysis of batteries, but the range too.
I think for the range, just if you want a safe car, then you can build a car around 350 miles, maybe pushing 400 miles. Still, it will still have all the safety components. You can push above 400 by making the can really thin, by taking away the pressure relief valves, by taking away all the heating and cooling systems. But then that just becomes way too dangerous to drive. So.
I don't know what that exact number is. I would suggest that you remember that right now, at this moment in the United States, if you had a exploding car cam, there's a car on fire right now on the side of the road. It's a gas-powered car, and it is flamingly, it's exploding right now. We managed to live through this, and it's not an issue, right? Nobody's saying don't have gas-powered cars because they blow up, but they blow up all the time. I passed one near Lawrence Expressway on 101 the other day. So it's not that they shouldn't be blowing up. It's important, but it's because you're moving stuff around, there's a volatility, like with gasoline, and the same thing with batteries. So I know that's a flippant answer, like to go along with all my other flippant answers, but that is absolutely true. Automobiles are not safe, and whether they're powered by cars or lithium ion. So,
I'd say on your second question in terms of lithium mining, I don't know if any of us here on the panel are experts on that, but I think it's certainly a huge concern because I think it's mostly in Bolivia and China. And they're not necessarily countries that are known for having the best worker health policies. And it's going to take consumer interest, the more people that own it and use it, to really care about it, and media to expose it if there is that sort of concern. We saw it with the iPhone and their manufacturing conditions in China and apparel. People got excited about that and that forced change. And if there's a couple mines and one mine is maybe a little bit more expensive but has a little better taking care of their workers, then someone like a Tesla may think about their brand, which Catherine was saying was super important.
Somewhere along the line, there's going to be a Nigerian cobalt mine along the line, right, with batteries, and we're going to have to address the pollution, that entire supply chain, when EVs penetration becomes big enough.
What about the end of life of the batteries?
There is a recyclability, and you know more. You're an investor in Tesla. They do have is there a take-back program? They can't use everything, but they can use a large amount of
yeah. Well, there's the second use, and then depending on, kind of gets back to one of the earlier questions, is what happens if we consume so much lithium that the price of lithium goes up? Then there might be some value after the second or third use to actually just break down the battery into its parts and pull out the lithium and then purify it and put it back into a new battery. I think we just haven't gotten to that point yet, and it's going to depend on a lot of. It's hard to predict because who knows where the price. Who knows who's going to get into it.
Important questions that we're going to have to confront in the next couple of years.
So everybody's just getting ready for the published report in that area. So the next few weeks we'll have a report out.
You want to give us a preview?
Well, the bottom line is that we still have to do a lot of work on the supply chain, try to understand where the issues are. And I reality that we just have to do a lot more coverage there. As far as the recycling goes, there are already a number of companies that are looking at recycling. Most of the battery About that? So yeah, there are a number of companies that are working in recycling, and there are companies that are trying to set up the infrastructure for that. Most of the battery manufacturers have long-term contracts with some of those manufacturers to recover materials. So the infrastructure is not quite in place yet, right? I mean, right now it's still cheaper to get the materials out of the ground than it is to try to recover them from existing batteries. But we see a future where that's no longer the case. So, and I want to illustrate that with the lead-acid battery. So the lead-acid battery at one point was a disposable product. We took those things and just dumped them in a landfill. And obviously that was not desirable because lead gets into the groundwater, et cetera. So we developed a recycling infrastructure for lead-acid, and lead-acid is now the most recycled product on the planet. 98%
in the United States, it's an environmental disaster in China.
Sure, and you know, but that's the thing. It can be done. We can do that if it's set up properly.
Yep.
And I think that that's the way it has to be set up for lithium-ion as well.
Okay, so I think just to kind of finish for everybody, I guess my question would be if we reconvene here in 3-5 years, what do you think we would have gotten wrong tonight, and what do you think we would have gotten right tonight? Who wants to take a first shot at it?
It's hard to say what you would have gotten wrong.
I'm just gonna. I'll try to leave with on an optimistic note. I think that the price drops that we're seeing are going to continue, and things like the Chevy Bolt or scooters are going to continue to drop in price. And I think that EV penetration is going to be surprisingly aggressive in the United States and the world.
Surprisingly aggressive. Okay. Anyone else want to take a crack at that one?
I think the incremental improvement in lithium-ion is going to saturate in the next 5 years, and then it will still be the mainstream battery using portable energy storage, but then new products will replace that.
So we're not going to get the 7% a year?
No, it's slowing down.
Okay. Anything else anyone wants to add? No?
My one hope is that we're not wrong about some of these innovative applications, like the scale in electric car adoption and some of these other things are not 10, 15 years away rather than 3 to 5.
And we hope we're not wrong about the administration stuff that
Right.
came up halfway through, right? Yeah. Okay. Well, thank you very much, everybody. And thank you all for being here. It's great time. Thank you, panelists.
Yes, thank you very much for sharing your perspective so freely. We really do appreciate it. On behalf of our audience, thank you. We have a very small gift for you that has no safety issues whatsoever. It is the Churchill Club speaker t-shirt. A recording of this video will be available on our YouTube channel shortly, hopefully within the next 24, but I'll say 48 hours, where you can find recordings of most of our other programs as well. Hope that you find that to be a useful resource on an ongoing basis. This is our last evening program of the year. Happy holidays to everybody. See you soon. You've been a terrific audience. Good night.